Hello, my name is Stephen Gottlieb, and I made up the Calculus 1 video. At this point, I would just love for you to sit back and view a sample demonstration that I made up. It's going to be a max-min problem. Now we get right into it. I want you to see a little bit of my teaching style. Suppose that you have 300 feet of fencing. You want to build a rectangular dog pen. Okay, so let's see what type of areas you can get. Now, I like to think of this distance being half of the perimeter, because the rest, these two sides, are going to be the same as the sides I just highlighted. Half of 300 is 150. So this portion has to use up 150. What if I do 1 foot by 149 feet? So far I used up 150 feet and then another 150. I just want to motivate that the answers to the square footage is going to be different depending upon your dimensions. And then we'll figure out the dimensions that we should build a rectangular dog pen so we get the largest area. 1 foot by 149. Well, 1 times 149 is 149. Feet times feet is feet squared. So this dimension dog pen will give us 149 square feet. Well, what if I made it a little bit different? What if I put 10 here? 10 feet, of course. So then this is going to be 140 feet, because these two add up to 150, half the perimeter. And we're going to have 140 feet along here, and 10 feet along here. The area, let me write an A for area. The area down here in this dog pen will be 140 feet times 10 feet. Well, 140 times 10 is 140 with another 0. And foot times foot is foot squared. You know what? I almost got 10 times more area here. I mean, 10 times this number is 1,490. This is square feet. This is just 1,400 square feet. This is almost 10 times more. Now, when you go to the fence store and you say, give me 300 feet of fencing, and they give you a price, say it's $2 a foot. They say $600. And you say, no. My neighbor, he built it this way. He got 1,400 square feet, and he paid $600 when he came last week. I'm only going to get 149 square feet. You shouldn't charge me 600. They're going to throw you out. They're not going to accept that argument. They're going to go, we don't care what you do with this 300 feet of fencing. You could go home and build this shaped dog pen or this shaped dog pen, or you can take the 300 feet after you walk out of fencing, and after you walk out, throw it in the garbage can. We don't care what you do with it. We charge by the foot, not by the square footage you're going to get. So there is a motivation here. What dimensions should I use so this area is the most? So our problem here is if you have 300 feet of fencing and you want to build a rectangular dog pen and you have all the area to build it on, that is, there's no constraints like this can't be more than 5 feet because, you know, maybe you have a building right here and you have another building right here and there's only 5 feet in between. Let's make believe we have no such constraint. Be nice if I found my eraser. Okay, here we go. So now we want to use some calculus to figure out what the dimensions should be. So I call this X and that Y. So right now, the area is X times Y. And I want to maximize that. I want to maximize, just call it max. I want to maximize A equals XY. But now, when you want to maximize something, especially in Calculus 1, you can only have one variable. So somehow we have to get rid of one of these. Well, remember, half the perimeter is X plus Y, and it equals to 150. If I bring the X over, I learned that Y is 150 take away X. This symbol means, among other things, it means whenever I see this, I can write that. Just remember it's X times Y. So A is X times Y. Now if I just write it like this, I'm only multiplying X by the 150. But that's Y is not 150. And even if it were, how come I have X times Y minus X? This whole thing is Y. And it says to multiply all of Y by X. So I have this, distributing 150 minus X squared. So I take the derivative of A, and I set it equal to 0. A prime is 150 minus 2x, and it does not equal 0. In my class, if you write it equals 0, I'm going to take some points off. I'm going to say, why does A prime equal 0? It doesn't. You, the student, want to set it equal to 0. Well, if you subtract those two quantities and you get equal 0, that means those two quantities must be equal. After all, if 2x isn't 150, 150 minus a number different than 150 won't be 0. We know 150 minus 150 equals 0. This must be 150. That's what I wrote. This must be 150. Well, 2 times 75 is 150. So X is 75. So our goal is to find the dimensions. Well, we found out what X is, 75. Now Y is 150 minus X. So Y is 150 minus X, which is 75, which happens to be 75 on its own. That's their max dog pen you should make. You should build it 75 feet by 75 feet. And let her see what the area is going to be. What is 75 times 75? Well, it's going to be 50, 25. I know that. 5 times 5 is 25. 35 plus 2 is 37. 7 times 5 is 35. 7 times 7 is 49, plus 3 is 52. So it's 5, 2, 6, 5. I hope I said that. I meant to say it if I didn't. 5625. You can get 5,625 square feet. A long, long ways from doing 1 foot by 149 feet and only getting 149 feet square. I mean, I understand you're not going to ever build a dog pen 1 foot because your dog is probably 2 feet wide. But just to point out, I mean, it's way different. It is much, much different. Like 30, 40 times larger. Okay, so I'm motivated that this problem is a serious problem. And if you go to your garage and you find 300 feet of fencing, and you're like, great, I can build a dog pen and It won't cost me anything for the fencing. I already have it. Now, I have all the land in the world, or I have at least this much or square footage to put the dog pen down in. Why not give the dog the largest area to play in? 6,000 feet, over 5,000 feet, or just over 100 feet. You really should know how to do this to maximize your dog's dog pen. Okay, this completes the sample demonstration for Calculus 1. Hope you learned a little bit about how to do max-min problems. Most of all, I wish you great success in your Calc 1 class, and thank you very much for viewing my video to the end.